Okay, guys, I'll start my talk. I'll talk about how our engineering team at CA Technology IT department accelerate the digital transformations with Neo4j and the graph technologies. So I'm Dr. Peng. So I'm a software engineer and leading the research and the development work inside the global information systems within CA Technologies. So before joining CA Technologies, I came from an academic background, studying the cosmic ray transports, so which could be leveraged to estimate the radiation levels. So in the next decade, if we are going to colonizing Mars, so I may work on predicting solar storms and suggest you to stay underground if there's a solar storm coming and the radiation level is too high. So that's my background. So when I joined CA Technologies, so we're undergoing digital transformations. So today, I'm going to talk about is to share with you the experiences and lessons we learned so far, and how we leverage Neo and graph technologies to solve the graph-related challenges. So this is the overview of the talk. So I talk about the challenges we have faced, the way we approach it. And we approach it in 3 steps. So organize our data, continuously enrich it, and then making more sense out of it. So given the size of the problem, so for a smaller size of the problems, this is the same philosophy we applied during this process. So if there's one take-home messages for you guys, I'd like to be that. So if you want to achieve something, attacking something, approach something, just do it, and do it incrementally and iteratively. So, the time I joined the company, so one of our challenges is we want to move our sales models, move some of our products into the digital sales domain. So leveraging the subscription types of sales models. So that means we as an engineering team has to working on the data infrastructures to deal with order of magnitude more data to coverage as much as we can the customer footprints along the user journeys. So across the digital sales, marketing, supports, and how they interact with our marketing campaigns, how they visit our websites, and how they use our products. So as many footprints as we can. So in order to do this, so usually data are within the big organizations such as CA Technologies are living in different business units, different departments, different product development teams. We want to horizontally integrating these informations between departments, between business units, between teams. Even within the same domain, vertically we have to deal with data coming from different sources, data coming from different formats, data coming from different versions. Those are all the challenges we face. So, and finally, moreover, another very important part that differentiates us from a traditional IT department, just providing supporting tasks, is that we want to provide and deliver more and more business intelligence to our business teams, deliver more values to them. So in order to do that, so we have to brew our own data science products, services. So to be able to do that, we need a new way to manage our data infrastructures and to manage the data science life cycle of the data science products and services, and integrate well with the previously other types of application development or IT enablement activities. So these are all the challenges, right? So how should we approach that? So I think out of many activities we have done, out of the many key elements we have implemented, I think I want to identify three parts that I think are very valuable to share. So comes from the three key elements of people, process, and culture, right? So in order to do this, so apart from the previous traditional IT departments, we have to incorporate people with different skill sets into a cross-functional team. We're working together, so towards a shared target, shared goal to increase our revenue, to be more cost efficient, and only in this way we work together very closely, and we can move in a very fast and iterative manner. So the second part is, so it will differ from companies to companies. So the second part is the process. So how to make the workflow working more interactively, responsively. And we leverage the agile practice in our application development, in our infrastructure building, in our data science teamwork. And we think that's a very important part that we to achieve what we have achieved so far. So the next part is that we have a better understanding of the business problems, we have a good process, we have a better understanding of the data, we have a better understanding of our infrastructures, our company structures. And then the next thing is for the engineers. So we work out our best to choose the right tools for the right types of work, tasks, use cases, use stories, right? So that's where we found the problems related to graph. So we choose, we think, and we choose, and we experimented and chose Neo4j as the tool to solve the graph type problems. So this is one of the pipelines that I'm in production today in CA Technologies. So the problems it tries to solve is that try to generate and manage high-value customer contact lists for our business. So we leveraged a lot of technologies, microservices, Spark, cloud, but one of the most important part, I should say, is the Neo4j and accompany the graph type technologies. So to give us a better understanding of the data and to leverage that to provide a high quality data sets. So as you can imagine, right, the contact information, the customer information comes in the different sources in a very noisy, duplicated, and sometimes contradicted way. We created ingestion pipelines, we created hygiene pipelines, deduplication pipelines, leveraging microservices and Sparks to solve this problem. So Neo4j serves as a data persistent layer and also a very important layer to derive the insights, help us to better merge, resolve, and organize, manage the contact and their interactions in such a cleaner way. And then we use the Neo4j database to serve the applications. So this is very high level introduction of the production pipelines, one of the production pipelines that we are leveraging in CA Technology. So let me dive a little bit more on the engineering and data science piece from this part on. So as I said, we approach different problems, so leveraging the same philosophy, organize the data, so and then enrich the data and then making more sense out of it. So the first step is, so if you want to build a very reliable data or intelligent system, you want your ground to be very, very sturdy, right? So first we need to create a raw data layer so that we can always revert back to. If something happened, we can always redo everything, right? So on top of that, so what Neo4j, what a graph database offers is a very convenient way to model the heterogeneous data sources and the relations. And it is very flexible if you want to make some changes, and it's very fast to load the data in batch mode. So you can easily recreate your graph database in a proper cadence, so to your needs, based on your data size and transformation characteristics. So another thing that is very important when we first adopting graph database is that we ask our engineers try to use it, and they can easily and quickly adopt the technology, even though some of them are from a SQL world with no previous experience about too much of graph-related technologies. So let me give you some examples in this part, right? So if the data is coming from different sources, the same data might be existing in different sources. So leveraging graph, we can provide an abstracted mapping between these sources and organize it and manage it in a very convenient way. And in this way, we can communicate with different unit or department of businesses very to their needs. So the abstraction layer provides a very unified access, and then on top of that, we can build the implementations based on different use cases. So in graph, it's very convenient to do so. So secondly, if you want to make some change, data coming from different size and different sources, so representing different actions, different types of activities, you can just create new nodes and edges and record it inside this graph. And so by doing this, it's coming very easily to model this data. So yeah, definitely you can also do this in a star schema if you want to leverage SQL, but in graph it is very convenient, and the benefit will accumulate if you continue to do so. So, which I will show in the second step, that how we continuously enrich our data once we have a way to manage our data. So then, this is very important too. We want to very quickly build our database. So one of the a good practice pattern that we leverage is we use Spark to do the transformations from raw to responding files that is ready for graph database loading, and then we leverage batch loading to do some of the work, and some of other work we can also leverage the Neo4j's graph algo libraries to do so in a very efficient way to build your data in a proper cadence you choose. Okay, so then let's talk about the second step. Now you have a way to record, to manage, to represent your data inside your organization, your company. Then the big part is to continuously enrich it. So what do I mean by that? So it's for example, in our case, we want to manage the customer's touch points along the user journey. So we have this shared graph database, and then we can start to build connections of the existing dots, leveraging different techniques, and work together with the business, translate their business rules into new connections within this graph. And you can conveniently adding new connections. That's a very important part. So, and this gives us the capability to better understand the graphical connections. So in our case, is a user inside the user journey. So let me give you some examples in this case, okay? So this is very high level case. In this scenario, we have to, for customer, we have to incorporate data or information from different data banks, different data units, different data department, right? So, and you don't have to do a very heavy lifting stuff here, so you can just leverage the graph database to connect the data in a convenient way, and enhance your analytics across units, across boundaries. So this is another example how you can add more insights in that graph. So suppose Bob is an employee of ABC US. So ABC US is a child company of ABC, and it also has a child company in ABC New York. And by leveraging some other information, your data science team may come up with a better understanding how Bob actually is related to this organization inside this organizational hierarchy, right? In this case, the dotted lines will show the work of a data science team's work. So actually, Bob belongs to a dev department within ABC New York site, and it's not a financial department. So then, maybe another data science algorithms help us find out, okay, so if I want to sell a product, APIM, based on the history and based on the external informations, so you would want to, I would recommend the sales and marketing team to approach ABC companies for product APIM. And then all of a sudden, so your business team knows that, okay, I should contact Bob for this product, right? So by continuously enrich your graph database by more and more technologies, you're actually building a knowledge graph. So by leveraging that knowledge graph, a lot of very insightful informations could be mined out of it. And that's what I mean, you continuously enrich data. So now we build that. We have a way to manage our data sources. We have a better understanding of our data sources. We enriched our data with external informations, with insights, with data science work pipelines, and then we could do some more interesting stuff too. So we can, so graph, as we know, is very performant to do the queries towards passes, variable passes, long passes inside the graph database. So if you reach out to any guys within Neo4j, they will tell you, and they will train you on that too. So another part is leveraging the graph algorithm libraries. So we can find out community patterns of your data. We can also find out those most important nodes that will connect through them, that will connect you to more opportunities. So what is more interesting, which I will showcase here, give you some example here, is the third bullet and the fourth bullet. The third bullet is what we have done within CA Technologies. We leverage the graph, the natural language capabilities and the graph database to provide a convenient service for our sales and marketing guys. So let me give you an example. So in this case, so the sales ops or marketing guys, they don't have to know any SQL, any query languages, or they don't have to call us. So they don't have to call data scientists to figure out the data. So they won't. What they need to do is just by enriching our data sets with external knowledges, we can translate a natural language type questions, such as is ABM, American Business Map Incorporation, one of our customers? So we can translate that into a graph query and build everything behind the scene and spitting out answers to our sales, to our business teams in a very convenient way. So this will enhance their productivities. So to make them better to concentrate, they're very good at doing every day. So go beyond that. This is what in our labs we are trying to leverage the graph data to the next level. So if you're familiar with deep learning, or especially inside the natural language processing part, we basically what we're doing is like first step is we transform. So give an example. So if we are refining oil, we are transferring the raw oil into gases and then put gases into different kind of machines, cars, trucks, right? So here we are doing the same business here. So we for each word inside the sentence, for a sentence inside the document. So the way that the scientists see it is first step is we transform into embedding. So we can use different techniques to do the word embedding, and then once we have that word embedding, we can throw into different machine learning, deep learning frameworks to do further classification or clustering jobs. So here, what graph provided is another way to represent your nodes. So it's the way leveraging the nodes and edges and their relationships to provide another way to embed your informations, and based on that, and then we can leverage this embedding to do more types of deep learning experiments and the development on top of that. So one example is just here the first one, deep work, right? So you just randomly walk your nodes based on the edges we have through the graph structure, and then you can come up with embedding of that node. So all the rest are different techniques that leverages the graph and the edges and the relationships between the nodes and its neighbors to achieve the same task. Okay, so I think that wraps up everything I wanted to say here. So basically, if you're a business, try to work more closely with your engineering team. So if you're an engineer, so just to try different type of technologies towards different type of problems based on its nature and use cases. So feel free to contact me if you want to share or talk with me. So with that, thank you very much. So which part are you talking about? So creating the data pipeline or building a data science model or project?
I guess I was thinking overall.
Overall? I think we spend a lot of time with the business trying to understand their problems, their pain points. And on the data science part, we spend a lot of time. So on finding out the proper data sets they can work on, and also find out what types of problems that we can attach, right, approach, and carefully gauge the expectations with the business. So creating these effective feedback loops to move forward. So on adopting graph databases, we also did a lot of like experiment. So testing the performance, testing the setup, testing loading. So you have a list that you want to try, and also let the engineers to try to use it to get some feedbacks from them. So yeah, this is something requires time too.
So the question of the natural language search,
Yeah.
is that a product that you built or an aspirational?
It's an internal services we provided to our internal users.
So when I can say, which of our clients use this product, that will be generated in a Cypher query?
Yes, behind the scene. So the end user will only see the question they typed and the answer they get. So
Is that a text?
text, yeah. Yeah, because so in the production environment, we think about it. So in the production environment, in the business environment, it would be more like natural to just type. So given the very noisy environment, so the audio input might be interfered with other stuff. It's not a very good user experience.
And then I think the second part of that was importing external knowledge. Did you create like a field form for people to input into your graph?
We have to work very closely with the business to understand all the jargons, all the mappings that they're the expert in that domain, right? So not us. So we're engineers, right? Yeah. Yeah.
Spark. So you loading the raw data into Neo4j and then have Spark refine it?
Yeah, so it comes up for different steps. So when we're loading, we did some transformations, and that's not enough. So we have to leverage some microservice to improve the quality of the data. That's where the...
Persisted before you did the microservice.
So it has several stages. So some of the stage we just leverage on a file format. Some of the stage it's actually landing inside the graph database if it's necessary.
Depending on what you need.
Yeah. Cool. So, okay, so thank you very much.